4:13, but before we get into today's lesson, I just want to explain something really quickly. The way our school schedule is working out, your next month is not going to be a whole lot of fun. Basically, every Tuesday for the next week, mandatory testing for all of DODEA. Next week on Tuesday, you're going to be doing the ELA testing all day on Tuesday. The following Tuesday, you're going to be doing math testing for the entire day. The following week, you'll be doing math testing for half of the day. So there's going to be a changed schedule for the next 3 Tuesdays. Basically, you're going to be in your seminars for the entire day on Tuesdays. There are going to be some people who are going to be pulled out if you have small group testing or need extra time. So, and some of you like this Miamata seminar will be switched to other seminars. We'll give you all that information before next week, but just realize you're going to be doing a lot of testing over the next 3 weeks. As part of that, Ken and I want to try to get you as ready as we can for it. So we're actually cutting out our initial activities that we've been doing, including the math minute, because we want to try to get as much instruction time as we can. And we are going to be basically kind of doubling up on lessons. Okay? Mr. Chan just did the work. Your math is now at 69. So stop the writing. Just listen. What we're doing, what our intent is, we're trying to expose you to all of these different things. Your math is going to increase a lot faster than what we are going to be doing in class for now. But remember, that score is not going in until the end of the year. So once we finish all this testing over the next 3 weeks, we are intending to give you guys a few days of classwork, catch up on your math yet. So don't kill yourself trying to get there unless you want. If you want free time later on, it might not be bad. But just understand, this is where we should be based on the lessons we're teaching. If you're there, that's awesome. If you're not there yet, you've got until the end of the quarter, and we will be giving you extra time. Is everybody okay with everything I just said? What part are you not okay with? Honestly, testing, I don't have a choice. If it were up to me, I would not be doing testing. First level here. Okay. Yeah, that part's done. Okay. 3, 2. Mason.
Is it going like on a record or like grades?
No, this is the one that goes with your permanent record.
What?
No, this is actually kind of where it's like the test that you guys just took. You'll be getting back next week. I'll be honest, overall scores aren't great, but no one will ever see that test. The test you're taking over the next 3 weeks goes in your permanent file, and everybody who is, if you go to a different school, that score is one of the things they will see when you show up. So, no, it doesn't count for your grade. It's actually even more important than that. It goes in what we call your cumulative file, your permanent academic file. So you really need to do your best. That's why we're accelerating our teaching to help you expose to the concepts to make sure you're as ready as you can be for them. Yes.
Why do I keep it permanent and a permanent record?
Snapshot of where you are now. Snapshot of you. Every student in DODEA takes the exact same test. So every student is getting the exact same test on the exact same condition. So if I'm trying to compare what you're doing here to what they're doing on mainland in Japan or in Korea or over in Germany, this is everybody's taking the same test. So if you have the same test, it's a lot easier to compare the results. So our first step, we're going to do 2 different types of equations today. We're going to do addition equations and multiplication equations. So in order to get you prepared for that, we're going to do a few review operations. I will say, having graded all of the first pages of the test, it is shocking the number of you that don't remember how to add and subtract brackets. I'm quite shocked at the number of people who did this and said, oh, 3 plus 4 is 7, 7 plus 5 is 12, this equals 7, 12. No, it does not. So we're going to do a couple of reviews like this to try and get everybody back in track. But we need you guys to answer these 4 questions. Move forward. We'll give you guys about 4 minutes. This isn't too hard because it's 3rd grade standard, but we're just making sure you guys are keeping track of it. If I'm adding decimals, what is my whole key? What's the rule?
You have to line up the decimal point.
Also, I need to line my decimal points up. So I'm just going to put this one underneath, line my decimal points up, make sure all of my all my place values are lined up, and then I just add. 7 and 3 is 10. 13 and 1 is 14. My decimal comes straight down. 13 and 1 is 14. What about for subtracting? What's my rule? The decimal point. Same rule. Now I'm just again subtracting by place value. Need to borrow. Gives me a 6. 6 minus 6 is 0. My decimal comes straight down. 3 and 6,000. Okay, it changes when I get the fraction. What is my fraction rule?
You have to have the same denominator.
Common denominator, meaning my 7 and 5 have to be the same. I've got to have the same denominator in order to add them. So 35 is where they meet. Anything I do to the bottom to get there, I must also do to the top. So that becomes 15. Guys, way too much chatter. Stop the chatter. If you have a question, raise your hand. To get the 5 is 35, I need to multiply by 7. So I multiply both by 7. That becomes 28 over 35. Once my denominator is the same, now I just leave it. So now I'm just adding the numerator. So 15 and 28 is going to get me 43. That is an improper fraction, meaning I still need to simplify. 35 will go into 43 one whole time with 8 left over. Same rule for subtracting fractions. Must have a common denominator. So 3 and 4 are going to need at 12. So I'm multiplying these by 4, these by 3, gives me 80 over 12, minus 45 over 12. Again, once my denominators are the same, I just keep it. Now I'm subtracting the top numbers. That gives me 35 over 12. In order to simplify, how many times does 12 go into 35? It goes twice without going over and leaves me 11 left. 2 and 11, 12. And your final answer. Yes?
I think it's
43 minus 35.
43.
Yes.
28 plus 15.
43. 43 minus 35 gives me 8. Any questions on your review piece?
No.
Okay. Go to the next page. And we said again, we cut a lot of pages out. We're trying to pick the ones that we get the concept. So yeah, I'm going to be skipping quite a few pages. I ordered 414. So we're going to go through a process where you can use a double number line to solve an equation. I'll be honest, we're not going to spend a ton of time on this because we don't expect you to solve it this way. We're going to show you a much simpler way to do it, but this will at least help you visualize what's happening. So if I look at a double number line for x plus 10 and 15, my equal sign just means they're on separate number lines. That's for him. I'm going to choose off by one on that. Thank you for that question. It's 415. Now, if I want to solve for x, I know that this is at x plus 10, right? So where's x going to be? Left. So if I'm going to draw x, it's going to be back here. How far back do I have to go to get to x?
10.
10. So what am I going to do to the bottom side? Subtract by 10 and I get 5. Does that make sense? So what property did I use from last time's homework,
Yeah, the next
David? Okay there.
I don't subtraction along with medium equality.
Good. Subtraction property of equality. I subtracted the same number from both sides of my equation. Yes?
Yeah.
When I did that, I moved that whole barbell 10 units to the left so that I now know that x equals 5. So I can rewrite on this double number line, I can rewrite this as an equation of x equals 5. How can I check that x equals 5 is the solution to the equation? What do you guys say? Remember, our initial equation was here, right? So if it's x plus 10 equals 15, how can I check that the solution is x plus 5? What do we call when I put that number in for the variable? What's the math term?
No. Just the level 5.
What do I call it when I take a number and I put it into the equation? Substitution. So I can substitute the 5 in for my variable. I can rewrite my equation. 5 plus 10 equals 15. What's 5 plus 10?
15.
Does 15 equal 15?
Yeah.
Check. We just checked our equation. So how can I check? Substitute the value in the equation. Once you have a solution, substitute that value back in, see if it makes sense. And we already answered this. The property of equality we used was
Subtraction.
subtraction, property of equality. Oh no, you have to write down the answer. Wow, I didn't expect that in this class. I will say it's kind of a mixed blessing, especially in this curriculum. I was old school where it was like just do the math, but this is kind of the new wave of you need to be able to understand the math, and then we'll show you how to do it. This is a kind of a form of common core, yes. Okay, so now that we've given you an example, we need to use a double number line to determine the value that makes each equation true, identify the property, and check your solution. So you've got 3 major things you do. Use the double line to determine the value, identify the property you use, and check your solution. So they've given you the equation. So I'm going to help you guys on the first one as an example. The first one is going to be p plus 10. And my answer is 17. But I need to solve, meaning I need to go find where p is. How did I get to p? So if I subtract 10 from 17, where do I get?
7.
So my solution is p equals 7. I need to identify the property I use. What property did I use?
Subtraction something equality.
Okay. And I need to check my solution. Not the property. To check my solution, all I'm going to do is take my solution, substitute that value into my initial equation. So we say 7 plus 10 equals 17. 7 plus 10 is 17. The 17 equals 17. Okay. Everybody understand what you're required to do? Okay. Good luck. We got about 4 minutes. Okay, our next one, we should have done 14 plus Q. And 2. So if I want to figure out where Q is, where am I going? Subtracting. So I'm going back here, 14 to Q. I don't know why I shouldn't draw a Q there. Q. And I went back 14, yes? So I go back 14 from 32, I get 18. What property did I use? Subtraction property of equality. I still need to do my check. So we're going to take our value of q equals 18 and substitute it into our equation. 14 plus 18 equals 32. 14 plus 18 is 32. 32 equals 32. Check. Our next one. Doesn't matter which one is first.
No.
Not really. So I can do 90 and x plus 64. If you're like Mr. Chan, you always want your variable on top. That's fine. It's an equation, so both sides are the same. From here, in order to get to x, I'm going back 64, so I'm going back quite a bit. Meaning 90 minus 64 is going to give me 3026. Yeah, I said it first and then said I had to borrow from that. So x equals 26 is my solution. What property do we use? Fraction property equality. And I still need to do my check. So I go back to my initial equation. 90 equals 26 plus 64. I add those two together. 90 equals 90. And we have a check. Questions? Okay, we've got a few definitions. Hope we have your highlighters with you. First one, what we call a one-step equation. A one-step equation is an equation you solve using only one operation. So the key in our one-step equations is only using one operation to solve them. Later on, we will hopefully at some point get to two-step equations. In order to solve these equations, we are going to be using inverse operations. These are pairs of operations that reverse the effects of each other. So those are the ones you kind of consider opposites: addition and subtraction, multiplication and division. Those are inverse operations. The other property that I'm bringing up here is actually really important. It's the additive identity property, which states for any number m, m plus 0 equals m. In other words, when you add 0 to any number, it stays the same. It keeps its identity. That property is actually mathematically the reason we are going to be doing everything that we're doing in the addition equation. Because I know once I get to the point where I'm adding 0 to a number, whatever's on the other side is what that number equals. Because if I add 0 to any number, it doesn't change its identity. So that gives you the mathematical discourse background behind the words we want to be hearing you say. And these are this is mathematically what we are doing. Okay, let's look at it. So if I were to do the solution of h plus 6 equals 19, we can use the double number line like we just did. We say h plus 6 is on top, 19 is on the bottom. In order to get to 8, I'm taking 6 away, yes? And I also take 6 away from the 19, and I get to 13. Algebraically, if we're doing this, instead of a double number line, if we're just using the equations, all I'm saying is h plus 6 is 19. I'm taking 6 away from the 8 so that I can get h plus 0. But our subtraction property of equality says if I take 6 away from this side, I also need to take 6 away from this side to keep my equation equal, correct? Yeah. Meaning, h plus 0, additive identity property of 0, means this side is now just h equals 13. That is what we call our solution. That was one of your math terms from last night. Is this starting to make sense for everyone? Okay, so mathematically, I'm actually going to have you guys write this down because all of our one-step equations are going to work the same way. I'll be honest with you guys. When I first started teaching math, I wasn't doing it right because for me, a lot of this stuff was instinctive. And so I was teaching my students, and I had a lot of students that were failing. So I went back to the drawing board, and I started looking at their work, and I said, how can I help them get this correct every time? So I built an algorithm, and if you guys will follow, we'll help you solve this every single time. So go ahead and write this down. I'm sorry, Mr. Kim. Yes, have your pencils ready. Got quite a bit to write. And unfortunately, we don't have a whole lot of space here. We're going to kind of spread it out. There's 4 steps to our solving equation. Step 1, this was actually one of the last steps I added. Because to me, this was so instinctive, I didn't think you needed to. But after working with 6th graders for a while, I realized, yeah, I need to be this basic. So the first thing I want you guys to do, circle, let me write it properly, circle the variable, and draw a line through the equal sign. So unfortunately, we've got a problem right down here in number 2 that we're going to use as our example for how to do this. So our first step is just saying, circle your variable, in this case it's a t, draw a line through the equal sign. Okay? Our second step is find the number with the variable. This is really important because the whole idea in solving an equation is we have to get our variable by itself. And that's part of the reason I added this line in. I found that students were still having trouble figuring out the number that they needed to work with. But once you put that line in there, it should become really, really clear to everybody. So if I look at this equation, what number is with t? 24. So I now know the number I'm working with, which leads to our third step. Our third step is do the opposite operation on both sides with that number. So now I'm looking at my equation. I say, okay, 24 is with my variable. What operation is that? Addition. So the opposite is going to be subtraction. So I'm going to subtract 24 from both sides, which is another part of that wall, to make sure that I'm doing it to both sides of my equation. Okay? Step 4 is basically just wrapping it up. Solve, simplify if needed. So to solve, all I'm doing is I'm saying 24 minus 24, 0, t plus 0 equals t. Because 24 minus 24, those are just going away. 85 minus 24, now I'm just doing subtraction. 5 minus 4 is 1. 8 minus 2 is 6. So my solution is t equals 61. That's in simplest form, so I don't have any. Really, the simplifying is going to be in probably you have a fraction involved. So that's not going to happen all that often. Now we're on the last step, checking my solution. How do I check my solution? I literally just substitute 61 back into my equation. 61 plus 24 equals 85. 61 plus 24, I add those together, I get 85. Does 85 equal 85? Yep. So, which property did I use to maintain the equality? Subtraction property of equality, because the opposite of multiplying is subtracting. But subtraction property of equality says I have to do it to both sides. Did I say something wrong, Mr. Chairman?
You said the opposite.
The opposite of addition is subtraction. Thank you. Since that's on recording, I want to make sure that correction was heard by everybody. that make sense? So we use subtract the property of equality. Again, you're always going to use the opposite operation. And that property of equality is what says I have to do it on both sides to keep my equation equal. But if you do that, it leads you straight to your solution. Is this starting to make sense for you? Okay, we've got one more chance for you to get practice on this page. Then we'll go to the next page. So I'll give you guys about, it shouldn't take more than 30 seconds to solve this. I'll give you 1 minute. Time. Again, the process is the same. I start by circling my variable. The number with it is a 12, the operation is addition. So the opposite is subtraction. Both sides of my equation. So I have m on this side, 35 minus 12 gives 23. There's my solution. Now I have to do my check, which means I'm just going to substitute that value back into my original equation and see if it's actually true. 12 plus 23 gives me 35. 35 equals 35. So yes, we have a check. Our solution is good. Does it make sense?
Yeah.
Mason, why are you leaning in your chair? You know better. Okay, now you guys have had a chance to see it. Here's your chance. Now guys, here's where you're going to see if you will follow the algorithm. This should be easy. Don't get caught up in the numbers. But it also doesn't matter which side our variable's on. That's part of the reason for circling your variable and drawing that line. You're focused on the side with your variable. Whatever's with it, we've got to get rid of. What's left on the other side is what it equals. You have 6 chances. Because of the time, we still have to do all the multiplication. We're only going to give you guys about 6 minutes to try to see how many of these you guys can knock out in 6 minutes. Go. I'm not going to do all of these because we still have all the multiplication ones to get through, but I'm going to give a couple just to make sure everybody understands your processing. Circle your variable. The opposite of adding 120 is subtracting 120. Do that to both sides. I have y gives me 5, 9, 195. It didn't say check my solution, so I have to do that. 120 plus 195 equals 315. I add those together, I get 315. 315 equals 315, check. Here's my variable. Draw my line. Gauss is adding 5 and 6,700. It's subtracting 5 and 6,700. Remember your rule. Make sure you line up your decimal places. Now I'm just subtracting. 2, my decimal, 7. Here's where the process really should be helpful for you. Because it doesn't matter which side of the equation my variable is on. If I'm circling it and drawing the line, it should help you focus in on what you need to do. What's the opposite of adding 1,699? Subtracting 1,699. So these are going away. I've got a left on this side. Now I just do the math. I have to borrow 7, borrow 5, borrow gives me a 6. So a equals 657. So 2, 3, 5, 6 equals 657 plus 1699. Add those together. 657 gives me 16, 14, 15, 13. 2356 equals 2356. And actually add it up, so we have a check. Okay? I'm not going to do the fractions because we have enough issues with the fraction rules. I want you guys instead, let's go to page 424. Page 424. I'm going to go through this one really quickly because I really want to get to the last part of our lesson. On this one, I have 3 equivalent equations. 2n is 6, 4n is 12, 7n is 21. To actually write the equation, all I'm doing is taking each side of that double number line and putting an equal sign in between it. So 2n equals 6, 4n equals 12, 7n equals 21. What is the value of n that makes all the equations true? What value of n would I put in to get the same answer? Anyone who doesn't see that? n equals 3. That's the value that works for all of them. How can I check that the value you determined in question 2 makes all the equations true? What do you mean? So what do we call that process? If I take the value and put it in the original equation, what is that? Substitute. Good. So I can substitute the value in. So I'd say 2 times 3 equals 6. 6 equals 6. Check. Can I do that for all three?
Yeah.
Yes. Is this making sense so far?
Yes.
Good. Okay, so here's where I wanted to get us to so that we can get to actually doing our solutions. I now have 2x equals 6. If I want to know the value of x, and it's 2x equals 6, where would I find x on my double number line? On the top, good. So where would it be located? And does it matter where I locate it on the number line? Aria? It does, right? Aria, thank you. Focus in my mind. I keep doing that for Aria all year. So halfway between is going to be my x. So what's going to be halfway between 0 and 6? 3. So I now have my solution at x equals 3. Does that make sense?
Yes.
Okay. Now, let's look at it doing it mathematically using that exact same process that we gave you. So if I circle my variable, draw my line. What does it mean if I have a number written beside my variable? What operation is that? Multiplication. So the opposite would be division. So I'm going to divide both sides by that number. Divide both sides by 3. Here's why we do this. What is 3 divided by 3? 1. So this now equals 1x. Now we haven't talked about that. We gave you the addition property of 0. It says if I add 0 to the number, it equals that number. This is what we call the multiplicative identity of 1. Multiplicative. If I multiply any number by 1, it equals that number. So any number I multiply by 1 is just that number, yes? That's why we're doing what we're doing. So I need to get that 3 to a 1. How do I do that? Divide by 3. So that makes it 1 times x. On the other side, 12 divided by 3 is 4. So I can now rewrite that as x equals 4. Should I check my solution?
Yep.
Yep. So I go 3 times 4 equals 12. 3 times 4 is 12. 12 equals 12. Yeah. On my double number line, here's where it gets a little more complex. As I get more intervals, 3x means I need to have 3 intervals to get there, right? I have x, then 2x, then 3x to get to where I was. Meaning, on the bottom side, I now need 3 intervals to get to 12. So what intervals would I use to get to 12 in 3 steps? 4, 8, then 12. Yes? So we have, again, our solution, x equals 4. I'll be honest, double number lines are going to get really, really hard as these numbers get more difficult. They're going to be far better served if you're comfortable with solving them algebraically. It's by far the easier way to do it. We just want you to understand why the math works. Questions so far? Okay. So, I'm going to give you guys 30 seconds to solve number 2. You don't have to graph it if you want to, but use the algorithm and see if you can solve it.
Yeah.
My variable. What's the opposite of multiplying by 7? Divide by 7 that becomes 1, so this side is that. 16 divided by 7. 9. I go back to my original equation to substitute. 7 times 9 is 3. So you can double number line, you would have had to have 7 different intervals on here. And you had to have x, 2x, 3x, 4x, 5x, and 6x. And then below those, you have each of those values. You started at 9, 18, 27, 36, 45, 54, 63. If you do it, yeah, you can see how this number line gets really clumsy as you get bigger numbers. Let's check it out. Fraction.
No.
So if I have fractions, then I'm kind of going the opposite way, right? If I had multiplication, I had to come back to find x. But now if I'm only giving you a part of x, I need to figure out how do I get to the whole thing. So my denominator is going to kind of focus me in on how I would get to the actual value. 1/3 x, 2/3 x, and then I would finally get that. Yeah? You get a whole number. So if my first interval was 2 to get to 1/3, what would be my value then at 2/3?
4.
4.
Yeah, 4.
Because I've gone up one interval here. What's different is how that interval is placed. The top is in thirds of x, the bottom is going by 2. So now what would be my third interval?
6.
So my solution is I need to check the solution. So I'm going to put it in. 1/3 times 6 equals 2. Well, to multiply by a whole number, I need to put it over 1. 1 times 6 is 6. 1. 6 divided by 3 is 2. 2 equals 2, so it does work. Here's where this gets a little more complex. Let's talk about it. If I have my expression or my equation, 1/3 x equals 2, and we do the process we just did, I need to circle my variable, draw a line through the equal sign. It's still side by side, isn't it?
Yeah.
Yeah, so that means it is. No. What operation is it if I have a number then a variable?
If we multiplication property.
Yes, if I write a number beside a variable, and there's no other sign, no.
Can you just tell us?
Yeah, that.
Y'all should know. Thank you, David. Multiplication. If I have a number beside a variable, that is my coefficient, and that means I am multiplying. So what is the opposite of multiplying by 1/3? But do we divide fractions? That's the process.
We multiply. We multiply it upside down.
Multiply by the what do you call the upside down?
Yeah.
Inverse or the reciprocal. So we don't actually divide fractions. We multiply by the reciprocal. Yeah? Does that make sense? Does that ring a bell for anybody?
Yeah.
If you've heard that before. You don't divide fractions, you multiply by the inverse. Multiply by the reciprocal. If you've heard that, raise your hand. Reciprocal is I just bring the number upside down. One at a time. We're recording. They're not going to hear anything we need to because the mic is over there. Mics and stuff. So I don't divide by 1/3. I multiply by the reciprocal, meaning I multiply. Reciprocal just means I take this number and I flip it upside down. So that becomes 3/1. But the multiplication property of equality we just talked about last lesson means if I do that on this side, I must also do it on this side. Correct? Why are we doing it? What's 3 times 1?
3.
What's 1 times 3?
3.
What's 3 over 3?
1.
1. So this becomes 1x. I have to take this an improper fraction. 2 times 3 is
6.
6. 1 times 1 is
1.
6 over 1 is
6.
so that equals 6. Did I just mathematically get the same solution?
Yeah.
Yeah. How did I do it? By multiplying by the reciprocal. If my coefficient is a fraction, when I'm dividing by a fraction, I don't divide. I multiply by the reciprocal. Why does this get important? Because the lines could work okay if my numerator is a 1. But as we get to the harder ones, and I'll show you this in a second, the math gets a lot more difficult. So we're not going to make you do the double number line unless you want to. We do want you to use the algorithm. Solve numbers 3 and 4. You have 2 minutes. Okay, this one, again, we just follow the process. Circle our variable, draw our line. Now, so multiplying by 1/4, multiplying by its reciprocal, 4/1. I do that to both sides. Multiplication product of equality. 4s will simplify out, those become 1, so I have x on this side. 7 goes over 1. 7 times 4 is 28. 28/1 is 28. I need to check my solution. 1/4 times 28 equals 7. If I put this over 1, I have a reduction. I can divide both of those by 4 because of 1 and 7. 1 times 7 is 7. 7 equals 7. Check. Here's our variable. On my line is equal. The opposite of multiplying by 1/2 is multiplying by 2/1. I do that to both sides. Multiplication property of equality. I now have 2's on both. That becomes x. Put this over 1. 5 times 2 is 10. Do my check. 1/2 times 10 equals 5. 10 goes over 1. I have one reduction. I divide both those by 2. 5 equals 5. Check. Multiplying by the reciprocal is your key, guys. Why? Because once I get to a coefficient like 4/7, doing this double number line has become such a pain, I'm not even going to show it to you. Okay? Instead, I just want you to be able to solve it. Actually, we want you to be able to just solve it. So if I do my equation, 4/7x equals 12. Here's my variable. What is the opposite of multiplying by 4/7? Multiply by the reciprocal, which is 7/4. So I can multiply this by 7/4. Multiplication property of equality. It's fine if I do that as long as I do it to both sides. Reductions. I have 4 on top and bottom. I have 7 top and bottom. 4 reasons we do this. So this is now 1. 1 times x is x. Multiplication by property of 1. I now have a reduction I can do here. I can divide both those by 4. That gives me 3 times 7, which is 21. If you don't like reductions, you can do the math. 12 times 7 is going to give me 84. 1 times 4 is going to give me 4, but now I need to take 84 and divide by 4. That's going to go twice. Bring down the 4, that's going to go once. You don't like reductions, you can do all of this. Your choice. As long as you don't make math errors, you'll get to the correct answer. But you've just now tripled the chance of a math error if you don't do reductions. It's up to you. Get comfortable with it or just ignore it. You can do the math. Okay, guys, we don't have a whole lot of time, so we've got 3 problems left. But I want to get over to the homework. So I'm going to, if you guys want to do that later, you may. Right now, I want you to go to page 422 if you didn't pull that out earlier. Good news for you. We're cutting out your journal entries. So we're doing the back side of both of the assignments. Guys, please be quiet. You do kind of need to pay attention to the directions on the other side. The directions tell you use the double number line. As far as we are concerned, this is Ken and one of those times, you do not have to do the double number line if you want. We just want you to be able to solve the equation. On this one, notice you're solving and checking each solution. Please make sure that you do both. So that's all you have for page 422. You've got 7 problems. You can do the structure if you want to. Then go to page 438. On this one, we didn't even give you double number lines. All you're doing, solve each and check your solution. Remember, it doesn't matter which side my variable is on. This one, it just says S over 3. If it's over 3, what does that mean? Now the dividing would be multiplication. Realize what you're doing. The rest of them should be pretty straightforward. Pay attention to your variables and where they're at and the number that is with them. Part 2, number 3. This one is just saying, I'll give you the easy way, solve for n. See if 58 is a works. If not, then you can answer part B and figure out what the actual numbers are. Okay? So you've only got about 13 problems total for your homework. You guys should be able to knock this out. Any questions? Okay, good luck, guys.